A square orbit? Well, sort of, at least from a lunar frame of reference. It's called a distant retrograde orbit. First, I'll describe the fascinating trajectory of a distant retrograde orbit, or DRO. Then I'll talk about why this orbit was used for the Artemis 1 moon mission. So here's our Earth-Moon system going along fine. Now we'll introduce the Orion spacecraft, which was inserted into a distant retrograde orbit. At first glance, from an Earthbound frame of reference, it looks like just another orbit around the Earth, sort of tagging alongside and weaving in and out of the Moon's orbit. But look what happens if we follow the Moon and make these tracers use the Moon as a frame of reference. From the Moon, the Orion spacecraft appears to be tracing out a nearly square orbit. Not only that, but its apparent motion with respect to the Moon is clockwise, opposite of the Moon's counterclockwise motion around the Earth. That, along with the fact that it keeps its distance from the Moon, leads to it being called a distant retrograde orbit. Once again, here's the actual path using the Earth as your frame of reference. But from the lunar orbital frame of reference, its motion appears to be impossible, especially if you zoom in on the Moon. This really surprised me the first time I saw it, which was actually quite recently. Like the L2 halo orbit of the James Webb Telescope, it goes against our intuition. In fact, this orbit utilizes the L1 and L2 Lagrange points of the Earth-Moon system. A distant retrograde orbit is made possible because of the interactions with the gravitational forces of both the Moon and the Earth. So it's a three-body gravitational interaction. On the recent Artemis 1 moon mission, they tested this orbit with the Orion capsule, but only for part of one orbit. This orbit can be used for lunar missions because it's an inexpensive and stable parking place. By inexpensive, I mean it takes a lot less fuel to steer a spacecraft into and out of this orbit than it does to force a spacecraft into low lunar orbits. Low lunar orbits are not stable because of the uneven distribution of the Moon's mass and therefore its gravity. So a low lunar orbit requires frequent firing of rockets for course correction. With this distant retrograde orbit, they can take their time because it takes a lot less fuel to keep it stable in this orbit. Something that I don't often hear NASA talk about is this upper booster rocket that will also take a loop around the Moon before heading off towards the Sun. You may recall that back in March of 2022, a spent Chinese booster crashed into the Moon. Hopefully this one will make its way out of orbit and plunge harmlessly into the Sun. Well, that's my take on a distant retrograde orbit. Thanks for watching.